This video we're going to talk about the effect of catalyst on the rate of reaction. So this is the last factor that will affect the rate of reactions. We're going to talk about what is catalyst first. So catalyst is a substance that can change the rate of reaction without itself being chemically changed at the end of the reaction. You have to pay attention to the definitions. There are two parts. The first part, its function is to change the rate of reaction. How to change? It can speed up the rate. It can also slow down the rate. But generally, we are talking about speeding up the rate. Second part, in the process, it may change chemically, but at the end of the reactions, you'll find that, they will be without being chemically changed. That means they will be the same at the end of the reaction. So in some cases, the catalyst, it may convert, to other chemical first, but before the end of the reaction, it will get back, to the original form. Or some of the catalysts, actually, it doesn't have any chemical reactions in the process. So there are two types of catalysts. One type, is called positive catalyst. It can increase the rate of reaction. But some of the catalysts, it will be negative catalyst. It is also known as inhibitor. They will decrease the rate of reaction. Normally, you can find this one in human bodies, in biology, things like that. So in general, catalysts will not be consumed after the reaction. This is very, very important. Will not be consumed, after the reaction. So the effect of catalyst we're going to study through the reactions, of the composition of hydrogen peroxide. So this is the hydrogen peroxide, H2O2. Long ago we talked about the electronic diagram of H2O2. It is a covalent bond. Should be something like this. O in the middle, H on both sides. So this is electronic diagram of H2O2. So this hydrogen peroxide is not stable, but the decomposition of hydrogen peroxide is not that fast. So therefore, we'll add MnO2, manganese 4 oxide, as a catalyst to catalyze the process of decomposition of hydrogen peroxide to water and oxygen. So in the process, the liquid will become liquid plus some oxygen. So oxygen will be formed. You can make use of measuring the change in the mass, of the reaction mixtures to monitor the rate of reaction. So this one, MnO2, the black powdered one. So this is powder. So you can see that they have a large surface area. It can have a better catalytic process. So this is a very interesting experiment. It's called Genie in a Bottle. So you can scan the QR code and have a look of this one. So independent variables, in this case, one of the experiments will have catalyst, the other one will without catalyst. And remember, in the process, we need to use H2O2. So maybe the volume of the H2O2, maybe the concentration of the H2O2, maybe the temperature of the H2O2, have to be kept the same. So the dependent variable, we're going to measure the mass of reaction mixture this time. So this will be the results. You'll find that without MnO2, it is not a horizontal line, but a slightly slanted line. It will be going down, in this way. But once we add MnO2, you'll find that the catalyst, the rate of reactions, will be very fast. So you can see the initial rate, for the one with catalyst, will be like this. Without catalyst is somewhere like this. So quite obviously, this one have a higher rate. So the results, with catalyst, with a higher initial rate, at the same time, it can react. The reaction will end earlier. So you can see the reaction end right here. But for this one, it ends somewhere here. I don't know, will it take ages, for the reaction to occur. So basically, if we have a catalyst, it can increase the rate of reaction. But remember, the catalyst itself, it will remain chemically unchanged at the end of the reaction. Or we say that it won't be consumed. So let's have a look of an examples. Right here, we're going to have a decomposition of hydrogen peroxide. Again, decomposition must be talking about one thing become many other kind of chemicals. So basically, it will be like this. Decomposition, one type of chemicals, and then become two types. So we have add potassium permanganate solution, okay, into it. At the same time, okay, we'll also add 200 cm cube 0.1% aqueous solution of hydrogen peroxide. So this is the reactant, hydrogen peroxide, very clearly. But what is this one? Potassium permanganate. So some of the potassium permanganate was reduced by water to give MnO2. Oh, so now we come to the catalyst. Okay, so MnO2 actually is a catalyst. So we are not putting directly the MnO2 into it. Okay, instead, okay, we have put some permanganate, MnO4 minus, and then hopefully it will turn into MnO2. Okay, so complete the balance equations, okay, of the half equation formation of MnO2 from permanganate. So you can balance this equation. But if you can't balance the equation, actually we can also use the skills that we've learned long ago, okay, when we have MnO4 minus and then go to MnO2, we can make use of three things to help us to balance half equation. That will be H2O, H plus, OH minus, or electrons. Is that right? But this one, you can see that actually we have OH minus, so it is in an alkaline media. So basically, to balance the alkaline media is more difficult. But like the skills that we have learned before, balance half equation in alkaline media, we can first do it in a acidic form first, and then both sides we add OH minus to see what happens. So basically, okay, we can try it out. MnO4 minus become MnO2. So what we have? We have 2 H2O and then 4 H plus here. Okay, and then electrons, okay, we'll have 3 electrons on the left. So now, okay, it is an acidic media. I want to convert it back into alkaline. 4H plus need 4 OH minus. So you add 4 OH minus on both sides. This one will become 4 water, as I have 2 water on the right hand side. So eventually you'll find that they can eliminate having 2 H2O, 3 electrons, and then MnO2 plus 4 OH minus. So this is exactly the same as the answer. Okay, so this is the skill, okay, to balance half equation in alkaline media. Do acid first and then add OH minus on both sides. B, what is the purpose of producing manganese 4 oxide? Like what we've said before, it acts as catalyst. Remember, don't give single word catalyst. You have to tell act as catalyst. It behaves like a catalyst. So the function of it is to increase the rate of reaction or increase the rate of decomposition of hydrogen peroxide. So write an equation for the decomposition of hydrogen peroxide. This is a very typical equation, so bear in mind. But if I want to include the catalyst as well, so I will write right above the arrows right there. Okay, so these equations very important. Please remember it. Just give you one more examples. Okay, right here we have hydrogen peroxide decompose much faster. This time we're using copper dioxide, so obviously this one, it is catalyst. Okay, so if you learn transition elements, you should know that, okay, manganese is a transition element. Copper is also a transition element. So therefore their chemical reaction is quite similar. Copper dioxide can also act as a catalyst. So the amount of copper dioxide we have used is 0.5 grams. Okay, add into 100 cm cube of hydrogen peroxide solution. Okay, and then, okay, at the end, okay, we'll put glowing spleen close to it, and we'll find that, okay, this glowing spleen will be relight. So the gas that we are talking about, it should be oxygen. So long haven't seen this kind of table. When you see this table, remember, identify the time that the reaction goes complete. So should be this one, because volume of gas remains 58, okay, time from 70 seconds. Okay, so part 1, write a chemical equation, the composition of hydrogen peroxide. So you see that is so common to be seen, but this time we are having copper dioxide. So you can see the answers. Okay, we'll have copper dioxide, okay, right above the arrows. And second one, what is the role of copper dioxide? As I've mentioned, act as catalyst. Okay, I know that catalyst you must remember, but act as, remember, this word is very important. Okay, and then plot a graph of the volume of gas evolved against time. Okay, so this is volume against time graph. So basically, remember the unit. Okay, and then you can plot a graph easily. Okay, so part D, describe how the rate change during the course of the reaction. During the course of the reaction means that at different stages of the reactions, I want you to describe the rates. Okay, so normally during the course of the reactions, we have separated the reaction into 3 parts. So skills here. Describe change during the course of the reactions. We'll focus on 3 parts. First, beginning of the reaction. Second one, as the reaction proceeds. That means after beginning, in the middle part, okay, how will the reaction change? And then third, it will be at the end of the reaction. So when you try to describe the course, okay, the change during the course of the reactions, you have to focus these 3 parts. At the beginning of the reactions, okay, the rate of reaction should be highest, because at this time, the concentration of the reactant is the highest. But as time goes by, the concentration drops, rates will also drop. Okay, so as the reaction proceeds, okay, we find the concentration of the reactant drops, so therefore the rate will drop. Lastly, okay, at the end of the reactions, if all the concentration of the reactants, okay, have goes complete, used it up, okay, then the rate, okay, will drop to 0. The reaction will then stop. Okay, so basically at the beginning, okay, highest rate. As the reaction proceeds, okay, rates decrease. Okay, finally the reaction rate becomes 0 at the end of the reactions. Okay, so basically it will be like that. So part F, what mass, when was the reaction complete? Just now forgot. So we mentioned 70. Okay, give the time, 70 seconds. Okay, 70 seconds. F, what mass of copper dioxide will be left in the flask after the end of the reaction? Okay, so this one we have 0.5 gram. As it is a catalyst, we know that the catalyst will not be consumed in the process. So therefore we can say that, okay, the mass of copper dioxide will be 0.5 gram. So last one, okay, sketch on your curve. Sketch on your graph, okay, the curve that will be obtained if copper dioxide has not been added. Without catalyst, the reaction rate should be slower, okay, lower rates, okay, the slope, okay, will be less steep slope, and also the time, okay, it will end later. So basically, okay, you have a less steep slope. You will ask, is it necessary to be like this? I don't know. Okay, for hydrogen peroxide, actually without the catalyst, okay, it won't be the reaction will not be that fast. Okay, but even you can draw like this slope like this way, okay, it will be all right because the end of time is out of range. Okay, so maybe you can draw this one or you can draw this one, will do, as long as I see that the rate of reactions is lower than the original one, and I see the end point, okay, is later. The end point here is later than the original one, then that will be fine. Okay, so basically, okay, the new graph, okay, have to be look like this. So to summarize, okay, this video, okay, we learned that catalysts can speed up the rate of reaction, and if we do a comparison, okay, between with catalyst and without catalyst, presence of catalyst will be the independent variable. Fixed variable, you have to focus on the concentration, volume, and also the temperature of the reaction mixture. And finally, because this one we are using electronic balance, okay, so we are measuring the mass of reaction mixture. So this is the sketch of the setup. Okay, pay attention to that. Okay, we got cotton wool plug here to allow the gas to escape, together prevent the exit, okay, or in this case hydrogen peroxide from jumping out. So the catalyst that we have used is MnO2. Okay, so what is catalyst? Remember the keywords. It changed the rate of reaction, but without being chemically changed at the end of reaction. So all these words are very important. If you see me say without being chemically changed, full stop, then I may argue, or actually in the process, some of the catalysts, they do change, okay, chemically. So if you say without chemically change, please add the word at the end of reaction. Or you may use without being consumed. That is true, okay, no matter which part it is, okay, it won't be consumed, okay. So number 3, sketch a curve, okay, so this is the curve, okay, that you may need to learn. The effect of having catalysts, okay, have a higher initial rate and also end earlier. And the skills, okay, we have learned today, okay, that will be describing the change during the course of reaction. What means by during the course of reactions? Remember, point out 3 points. 1, at the beginning of the reaction. 2nd, reaction proceed. 3rd, at the end of the reaction. That's all for this video. Bye bye.